Great. So welcome everyone. Thank you for joining us in this. It's going to be a story I'm going to be sharing with you, all of you. And this story is, obviously, as you already know, is how RS reduced costs and accelerated releases by moving to GraphOS Router. So we are in this all together. Sit back, relax, and if you have any questions, just save it to towards the end. So the story that we'll be sharing today is why we want to migrate to Router. And all this story is going to be divided by chapters. So the first chapter is the why. The second chapter will be all the challenges that we faced during this migration, which we're really interested in. The third one is the switch. So no spoilers. I'm going to keep that to the secret onto the third chapter, but keep in mind. And then as the last one, and the last chapter, is the rewards and the lessons learned. So let's dive in. So obviously, chapter 1, recognizing the need to move from gateway to router. RS has been running Apollo Federation for years, almost as much as a federation has existed. And as we continue to grow, we have seen our traffic increase from millions to billions of requests. This growth also brought new businesses requirements, such as the need for fine-grained schema control and the need to save money and reduce costs due to the increase of usage as we onboard new subgraph and consumers. And then we start looking into how we can achieve this. And Apollo Router provides these features out of the box. Otherwise, we would have to build plugins and tooling all around our Apollo gateway to maintain all of that. So that was the plan, migrate to Apollo Router. Now, how did we do it? Then we got into how we implement all these changes, how we migrate successfully from gateway to router. And with that in mind, as you can imagine, the main objective from the engineering and the business was seamless, zero downtime migration for the consumers. Obviously, that's always a dream, and that's all what we want to achieve as engineers, the seamless transition from one service to another if it's needed. And then we start looking at the migrations of how we can break down this project, this plan, how we're going to migrate successfully gateway to router. And we broke it down into these 4 areas. These 4 areas started with business logic, observability, migration strategy, and then going live. The going live was towards the end, obviously, but then, can I ask a question to the group here? How many are currently running Apollo Gateway in production at this time? Okay, cool. We'd like anyone to raise a hand to share which one is the biggest challenge that you're facing right now with the migration from gateway to router. Anyone?
Moving from Node.js to Rust.
Moving to Node.js to Rust. May I ask why?
When your company has certain stack and invested in libraries and solutions for certain languages, introducing a new language is a challenge.
Interesting. Anyone else would like to share a little another challenge that they're facing? Just work. Time. Yeah, no, I get you. We have a time constraint as well. Obviously, when we start looking into the business logic, back in the early days, when the dawn of the first subgraph, this was just an idea. And we created the first subgraph. We decided that our federation will have a clearly defined responsibilities to enhance maintainability. We focus on a modular design with a clear separation of concerns, making it easy to test, manage, and update, and also scale. This separation is what you can see here. A subgraph with a business logic, and an Apollo gateway as vanilla and light as possible. This separation allows developers to make changes and updates to the business logic without affecting the gateway itself, reducing the risk to introduce any bugs. So when we start looking at the business logic, this is not the part that we actually face any challenge. This was very easy, which was really good as well. Because when we were looking at the migration, and we start running the first test to see if we need to do any changes in particular to router when we come in, it was no. This is super easy. We just compare the built-in functionality from Router. We look at the very few things that we added into Gateway, such as metric for observability, some tracking, and we realized that that was already given by Router out of the box. So we say, now, business logic is done. This was super easy. This section was super easy. Now, that's why we say that sometimes less is more. By maintaining a streamlined architecture and focusing only on the essential functionalities, we enable greater flexibility, easy maintenance, and a reduced risk of errors. This simply guided our design choices and ultimately facilitated a smoother migration to the router, demonstrated that simplified can often lead to more effective solutions. So that's what we got. We were really happy at this stage. Now, the second challenge that we faced was observability. Now, observability we know that's really important. It's our KPIs, our monitors, our alerts, how we continue functioning seamless after any change, especially in a migration. So first, it's very important to highlight that Apollo Router uses OpenTelemetry. And now, how many of you are using OpenTelemetry right now? Okay, cool. Now we have a good hands over here. Nice. Now, OpenTelemetry has been a key player in the observability. However, this might be new for some organization, and it was new for us as well. So we have to present to the business, we need to enable OpenTelemetry in our Datadog agent. And the business came back to us, yes, we're going to be doing it. How OpenTelemetry works? What are the costs attached to OpenTelemetry? How do you ensure that it's not going to affect what you have running right now? So we have to present, we introduced a new system into our enterprise, which was a new challenge on its own, as we need to understand how OpenTelemetry works. It was a learning curve for all the team, for our team, for the engineers to understand how all of this fits, how OpenTelemetry fits into the Apollo Router and into our observability platform. So once it was enabled, we realized the significant amount of work that was involved into mapping Router's metrics to Datadog, to what we already have in place. Just bear in mind that we have been running Apollo Federation since 2020, and we have metrics, dashboards, alerts, all of these things built by us. So now we have all of this data, all of this rich data given by Router that we need to migrate, metrics, to make sure that they are still working. So this was a particularly interesting time-invested challenge, but how to say, it was very fun learning how OpenTelemetry works. I really enjoyed it, and it was really rich for the whole team. Now, this not only was about doing the mapping of the data that was coming from Router to our Datadog, which is our observability platform. It was also about how much it's going to cost. Datadog, a quick question, how many are using Datadog as an observability tool? Okay, quite a lot. Good. So you know that Datadog is an expensive tool and that we need to manage the cost effectively. And when we introduced Apollo Router, we realized that all the metrics given by Apollo Router, they just become custom metrics. And custom metrics, if they are not managed accordingly, depending on the dimension that are added by the Apollo Router and the Datadog agents, they can increase in cost incredibly high. So, and in this case, it was ridiculous high. And then we have to do an additional step, which was to manage the tags and manage the metrics that were coming out of Router, because it's really important to use the observability needs to be rich, but it needs to be value for the business, for the engineers. So there might be data that is coming out of Router that might not be, they might have much value for the business or to the engineers. So that was an interesting study, and what is valuable for us at this time, and how do we are cost aware of if something is increasing the cost of observability in the platform. Now, All the metrics, as I said, are generated, all the metrics generated by Apollo Router are custom metrics. And when we found in this high cost scenario, we implemented a reduced tag exclusion in our platform. This reduced the cost of our metrics, but in addition to that, we review all of our metrics to avoid over-observability. Focus on what we need, exactly on what we needed. So, with that in mind, it comes one of my favorite quotes of all time, slightly tweaked. With great observability comes great responsibility. So it's crucial to focus on the key metrics and data that align with the business and engineering goals and regularly assess the relevance and necessity of the data we collect to avoid overspending. Now, bear in mind with me here, because this was a particular challenge that we faced during the migration. So, we already covered the business logic, we covered observability. Now, how do we migrate the service itself, infrastructure-wise, from gateway to router? Now, RS infrastructure is bespoke, and we have constraints in our platform, which means that we need to try to find a solution that will satisfy the business. And what was the business objective? So we need to have zero downtime and seamless to the consumers. And as engineers, we have a requirement that if anything goes sideways, we have to have a rollback within 5 minutes. Okay? So our bespoke infrastructure limited our options to achieve what we desire. The business made it clear that we could not handle, we could not have a scheduled downtime to do this migration. So any change must have a role plan and a very clear that no interruptions or issues, hopefully during this migration. So with all of that, we tried the first migration strategy, canary release. Very common, very simple. We do it every day as a BAU. We couldn't do it. We just were restricted by our options in our infrastructure. And just to be clear, canary release is when you release a piece of code or to a subset of users to test if it's working or not. Then we attempt traffic redirectioning. So this one has an option that it could work, but the rollback, it was over 5 minutes. So we couldn't handle that at that time. And which is basically steering the traffic from one service to another. And then we look at how are we going to be doing this? We start scratching our heads. We start to figure out how we're going to achieve this. And then during one of those, as many Slack threads that we were having during that period, we realized that perhaps there is an easier solution, unconventional perhaps. And then we look at, we could migrate Apollo Gateway to router by shifting the state file that we use during deployments. Okay, so we use, and already spoiler, sorry, it's also known as a switch. So if you can imagine, we selected that as a migration strategy, but I'm going to explain how that works. Basically, we use Terraform. The state file of the gateway handles all the cloud resources. But then, by pointing router, which was a new project, to that state file for gateway, when we did a release, it looked like it was a BAU, business as usual. It was a very interesting approach because despite being an unconventional way to migrate a service, it was the easiest way to us because it was the closest one to a business as usual. And the rollback, it was like doing a revert of a deployment, which in this case was less than 5 minutes. So state file management, shifting the resources on that particular service was our chosen migration strategy. So now allow me to present you chapter 3, the switch, our chosen migration strategy and how we did it and everything that we planned for it. So now the switch. The switch, as we said, is shifting the state files, provided a rollback within less than 5 minutes, and gave us full control of the change, something that we were aiming to do. As engineers, we want to have that authority that said, if something goes wrong, I want to revert it. So that's what we did. But it's going ahead here, nothing went wrong, everything went fine. But then we have a checklist, and then this is what we presented to the business. So a rollback within 5 minutes, tested and documented. It was very clear that as this was an unconventional way to do a migration, we just have to thoroughly document and test that it was not going to cause an issue during the migration. We tested multiple times, we documented the whole process, we have everything ready to go, and then presented this to the business. Then we got the business approval. Obviously, de-risked the process and everything went fine. And then we decided to start rolling out the plan. 2 weeks running Apollo Router in a non-prod environment. So during this time, we ran multiple tests. We done performance testing. We done all the certain tests that we have on Gateway. And if you remember, Gateway is very light. It didn't have any plugins. It didn't have any business logic that we need to have custom unit tests. So all the tests that we have on Gateway, all tests that we test against our federation. So when we doing the migration to Router, that's the same test that we were running because we were testing an outcome as a consumer to our Apollo federation. Then we informed all our APIs and our stakeholders. We made sure that everything that we were doing, they were aware of the whole process. That way, if anything was not working during that period, during that testing period, they could inform us. And that's what they did. There was one of those consumers that they run not regularly, not a regular traffic, and we identify a header propagation that it was missing on our Apollo Router configuration. And then we fixed it during that 2 week process. Everything went fine. And then we have observability set up and ready to observe. All that was ready to go. And then we schedule the deployment outside of business hours. Why? Because we want to minimize any disruption by deploying during the low traffic periods. And then, drum roll please, if anyone can do it. Okay, and Router, it's alive! We took Router to production and everything went great. And after that, we would just start looking into, now Router is live. And what's next? What's next? All the rewards and the lessons learned during this migration and everything that we gained during the process. So, first of all, I mentioned earlier that one of the reasons we moved from Gateway to Router is because Router, out of the box, is given so much functionality. So we are focused on configure, not build. We don't want to build a whole set of features that's going to hold our projects, our notification, caching strategy, and all of these amazing features given by Router. Just like we saw today, Apollo connectors. And all of those things is just now given by Router. So this is our first thing that we always think when we're looking into a project. In this case, is configure, not build. Thanks to this migration and the amazing features that are available on Router, we have managed to increase our traffic from 2023 to 2024 for 4,000%. And this has been increased, this is adoption of Router, new consumers, new subgraph, and new activity that we are tracking as a service that we are just very proud of internally, that it works very well. But not just that. Hold it. There's a little bit more. When we deploy Router, we not only realize we have all these features, but it allows us to increase our API usage for 4,000% the last 12 months, but also to increase our throughput 5 times that we were running through Gateway. That 5 times is the same amount of services, containers that we were running with Gateway, which means that we didn't reduce any service, we just gained more availability for the same. It was amazing. We reduced the cost of ownership by 60%. Can I ask a question? Why we have a reduced cost of ownership? Any guesses? No one? Cool, I'll tell it, don't worry. So, imagine this. Gateway has all these dependencies to run locally. You have nodes, you have packages to run locally, you have configuration, you have all of these things that you have part of your gateway. Now you look at Router. Router itself, we run a Router Dockerized, which means that it's just Router there and the configuration file. That's it. By doing that, we reduce our regular maintenance that we do to compare to Gateway to Router by 60%. That's engineering time that we are not investing on a BAU regularly when maintaining Router now compared to Gateway. That's business value. Now that's 60% of the time that we can invest on doing something else, like enabling features on Router. In addition to that, we have a 24% decrease in common responses for P95. I mean, these are all benefits by moving to Router that we gain during this migration. But then there was something very interesting as well. We realized Apollo, if you're here, people from Apollo, you are very busy releasing regularly new features on Router, which means that we need to continuously be updating our Router image to be up to date. So we start looking at our BAU process and we introduce Renovate, which Renovate looks at all our dependencies and makes sure that almost as fast as Apollo is releasing new Router updates and new features, we get them as well. And all the testing that we have on the pipelines, all the testing that we have on the project, the confidence releasing Router on every new update is very high. So all of these changes go straight away and they go in. And then we are arriving towards the end now. And before I finish, if you want to learn more about the story for RS, join my manager tomorrow, along with Samantha from Wayfair and Baraden from Silo, to share about how GraphOS Router success stories, and learn more about the business and engineering perspective. And with that, thank you so much, everyone.